So let's quickly talk about epigenetics as a target for treatment, right? So lately I've talked about that epigenetics play a key and crucial role in maintaining and also giving us cancer, right? But you can also utilize the concept of epigenetics to kind of reverse this. So let's look at that. Remember, epigenetics, it's all about methylation. It's all about histone modification and non-coding RNA, so microRNA. So let's start off by looking at methylation. So remember methylation, and let's take an example here with 5-MC, right? Adding a methyl group to cytosine, you're getting 5-methylcytosine, and typically you see these CpG dinucleotides, and when you have a cluster of these CpG dinucleotides, then you have CpG islands, and these CpG islands are typically found in promoter regions. Now, what is important to understand is methylation, right, is when you're basically taking the DNA and wrapping it around the histone proteins more tightly. What you're doing here is you're silencing some genes. You're silencing some genes when this DNA wraps around the histone proteins more tightly, you could imagine here. And if you're silencing tumor suppressor genes, so these genes that suppress tumors, well, now you're in big trouble, because what is the function of these tumor suppressor genes? Well, it is to suppress tumors. So if you now are silencing these genes, now these tumors can begin to evolve. You could have proliferation down the line. You can have it metastasize, so spreading to other organs and things of that sort. Now, if you have hypermethylation, you have more methylation than demethylation. Remember, what are the enzymes responsible for methylation? Well, it is DNMTs. It is DNMTs. And DNMT1 is responsible for maintenance DNA methylation. And DNMT3A and 3B are responsible for de novo DNA methylation. So these are the enzymes responsible for hypermethylation. Going the other direction, suppose you have more demethylation than methylation, now you're having hypomethylation. The enzyme responsible for this is TETs, or 10-11 translocations. But what I wanted to say is you can have DNMT inhibitors. DNMT inhibitors are inhibiting your DNMTs. They're inhibiting your DNMTs. Meaning that these enzymes that cause hypermethylations are out of function now. And so now you could imagine that these enzymes don't work anymore, and the DNA will not suppress these genes. And specifically, if we're talking about tumor suppressor genes, they're no longer suppressing these tumor suppressor genes. And that is very, very, very good. Because what is the function of these tumor suppressor genes? Well, it is to suppress tumors. So DNMT inhibitors are really good if you have hypermethylation. Now let's talk about, on the other hand, about a specific histone modification. Let's talk about histone or acetylation. So acetylation meaning you're adding an acetyl group to a lysine residue on DNA. Now, in the same way with methylation, you can have acetylation and deacetylation. Acetylation, what is happening here is you're making the DNA wrap less tightly around the histone proteins. And so this can of course lead to relaxed chromatin, what we also call euchromatin. and this is HDACs that are responsible for that. But going in the other way, suppose you have HDACs now. These are responsible for deacetylation. So deacetylation, you're removing these acetyl groups now. Now you're getting condensed chromatin, which is not good because it is a little bit like methylation or hypermethylation, excuse me. It's of course completely different processes, but they have the same sort of implications. You're making the DNA wrap more tightly around the histone proteins, silencing these tumor suppressor genes, or it could silence these tumor suppressor genes, and now you're in big trouble. And what enzyme is responsible for deacetylation? HDACs. So if you have HDAC inhibitors to these enzymes, well, now you no longer have the same sort of activity in deacetylation, meaning you're going back to the relaxed chromatin again, which is good because now these tumor suppressor genes are being expressed and they can suppress tumors.